On example 12, not to be confused with this example 12, new. Find the equation of the tangent line to the graph of f of x equals 2 times the square root of x plus 3 at the point 1 comma 4. Well, when we write the equation of a tangent line, I need two very simple pieces of information, one of which is the point, which is conveniently given to me, and I need the slope. How am I going to get the slope? I'm going to find the derivative of this function at 1 using the limit definition. So I need my slope, and my slope will be equal to f prime of 1. That'll be my m. There we go. All right, so let's take your pick which one of the limit definitions that you want to use. We'll just use this traditional one here. F prime of 1 should be equal to the limit as h goes to 0 of, and then I'll build my little blueprint as f of 1 plus h minus f of 1 all over h. If you do this 4,000 times, I guarantee you you're going to have it memorized. It's just going to come to you very, very quickly. All right, now it's time for us to plug 1 plus h in for our x's and this one in for our x's and rewrite our limit. So f of 1 plus h becomes 2 times the square root of 1 plus h plus the 3, don't forget that thing, minus 4. Yeah, minus 4 over our h. Just a quick verification, if I were to stick 0 in here, I would get 1 plus 3 is 4, square root of 4 is 2, 2 times this, 2 is 4, 4 minus 4 is 0, over 0. Yeah, I get that indeterminate form. And probably what I'm going to go ahead and do is simplify the stuff that's inside here. I'll combine the 1 and the 3 up to get that, yes. All right, so indeterminate form, when I have square roots, how do I fix it? That's right. I multiply by a conjugate. I am going to rationalize the numerator. And the conjugate here is 2 times the square root of 4 plus h plus 4 on the top and the bottom. It's our fancy one. And of course, when we multiply our conjugates together, the middle term will cancel out. It's like the difference of 2 squares, so don't even worry about it. Don't even think about it. Don't even consider it. Limit as h goes to 0 of the 2 times the 2, 4. Square root times the square root is 4 plus h minus the 4 times the 4, 16. Over, and then keep the bottom factored, 2 square root 4 plus h plus 4. We're almost there. Just got to distribute here. It's 4 times 4 is 16 plus a 4h. And look at that, our 16s cancel. All right, and let's rewrite 1,000 more times before we can evaluate this limit. Across the top, the only thing that's left is a 4h, and on the bottom, an h, 2 square root 4 plus h plus 4. Whew. All right, man, calculus sure is a lot of writing. And notice that we have a common factor of h on the top and the bottom, which divide out, make that sucker a 1, and I think we're ready to evaluate the limit. Limit as h goes to 0, only a 4 up top, and 2 times the square root of 4 plus h plus my 4. Oh yeah, just a little secret here. My iPod crashed. This is the second time I recorded it. The first time was way better than this. Anyway, so I got, I think I can go ahead and take the limit, plug in 0 for my h. I have 4 over 2 square root of 4 plus 4. Square root of 4 is a 2. 2 times 2 is 4, so we get 4 over 4 plus 4. You might need to take out your calculator for this one and verify that it does actually reduce to just 1/2. Hey, what did we just find? Let me just recap it here. This was f prime of, I think it was 1, is equal to 1/2. That is the slope at x equals 1. It's the derivative. Derivative is the slope at that particular point. It's the slope of the tangent line. Speaking of the tangent line, I do believe this question actually asks for the equation of said tangent line. We will write that as well. We need that point was 1, 4. and our slope value right over here as well. So 1 y minus 4 is equal to our slope half x minus 1. Very nice, very nice. Okay, now of course we could leave our answer exactly like that. What I am going to do though is I'm going to go ahead and add this 4 over to the other side because I'm going to graph both of these things in Desmos just for funsies, just to verify that we did our work correctly, and also it's pretty satisfying to be able to zoom in on that point and see everything work out right. So I'm going to add the 4 over plus a half times x minus 1. All right, let's see. Decimals. Graphing calculator, our equation originally was y is equal to 2 times the square root of, I think it was x plus 3. There we go. And it's red. That's not going to work for me. Red's the color of a tangent line. Yeah. All right, we'll make it blue. We'll make it blue. Done. And on the second one, we'll type in our tangent line, which was y equals 4 plus a half parentheses x minus 1, I think. Oh, and the tangent line came up as blue. That's not official. That'll have to change. Oh, and let's make it dotted too. Great. And why not go ahead and plot our pointed tangency, 1, 4. Get it all together, and look how nice that is. Very satisfying, especially whenever we zoom in and demonstrate that local linearity aspect, that the function is really getting closer and closer to looking like that line right at that particular point, 1, 4. All right, so we just found the equation of the tangent line in red there, and the slope of that tangent line is the same thing as the slope at that particular point, which, one more time, is the derivative of the function at that point.